Hi, I am Syed on Maths Online. Today we will be discussing about the topic conformal transformation. In the last two videos we have already discussed about the transformation. W is equals to z square and W is equals to e power of z. Now we are going to discuss about the third transformation. So discuss the transformation. W is equals to z plus 1 by z, where this value of z is not equals to 0. So let us try to discuss this one. So now we will try to see how does the z plane maps into the w plane. So suppose if I take put the value of z to be equals to r e power of I theta. If I take this equation, z is equals to r e power of I theta. So in that case we have the value of w to be equals to, so given the value of w to be equals to z plus 1 by z. We know the value of w. The value of w we know it is u plus iv. So now if I try to plug in this value of w as well as the value of z over here, so we will be getting w to be equals to u plus iv is equals to, so the value of z is nothing but r e power of I theta plus it is 1 by z value is r e power of I theta, or this can be further written in the form of it is r e power of I theta plus 1 by r. Now this e power of I theta is in the denominator. If I take this value in the numerator, it becomes e power of minus of I theta. Or further, if you try to simplify this one, it is r into, we know the value of e power of I theta to be equals to cos theta plus I sin theta, right? Plus this 1 by r times of. So e power of minus I theta is there. So you can write that as cos theta minus I sin theta. So now if I try to group the values, so I can rewrite this value, just multiply this one, it's r cos theta plus I times of, multiply r times of sin theta. So multiply this 1 by r inside, 1 by r times of cos theta minus I times of, multiply, you will be getting 1 by r into sin theta. Or if I group the real terms over here, so these two terms if I try to see, so in both these terms you have cos theta common. So if I take cos theta common, what will be left out? R plus 1 by r will be left out into you have cos theta. Similarly over here if I try to observe, sin theta is common along with the value of I. So I will be taking I value common as well as the value of sin theta. So what will be left out here? R will be left out. Here what will be left out? Minus 1 by r will be left out. So I have separated the real term as well as the imaginary term. So let us try to equate on both the sides the real and imaginary terms. So equate real and imaginary terms. Equate real and imaginary terms. So if I try to equate, so the value of u will be equals to r plus 1 by r times of cos theta. Then if I equate the imaginary terms, coefficient of I, so v value will become r minus 1 by r times of sin theta. So you got the value of u, we have got the value of v. Now from these two, u and v, I need to eliminate the value of r as well as I need to eliminate the value of theta. So let us try to eliminate this r and theta from this particular equation itself. So let us take this as equation number 1. So the first thing that I am going to do over here is let us try to eliminate. Just decide which value you want to eliminate first, either theta or r. So suppose if I want to eliminate theta, so that's the first case I am taking. To eliminate the value of theta, what has to be done? So I have to separate this cos theta as well as sin theta. So from here, if I want to separate, just cross multiply this r plus 1 by r, we will be getting u divided by r plus 1 by r is equals to, what is left out here? Cos theta is left out. Similarly here, keeping sin theta as it is, cross multiply. We will be getting v by r minus 1 by r is equals to how much? Is equals to sin theta. So you got u divided by r plus 1 by r is equals to cos theta. V by r minus 1 by r is equals to sin theta. So once again, to eliminate this cos theta and sin theta, I will try to square and add this one. So squaring and adding, squaring and adding. So I am squaring and adding so that I get cos square theta plus sin square theta, which will become equals to 1. So that's the reason we need to square and add it. So if I square this value, we will be getting u square divided by r plus 1 by r whole square. Left hand side have squared, plus here also is square it, v square divided by r minus 1 by r whole square is equals to, now you need to square and add this right hand side. You will be getting cos square theta plus sin square theta. Its value is nothing but 1. U square divided by r plus 1 by r whole square plus v square by r minus 1 by r whole square. So as you know, this value is equals to 1. So theta is eliminated. So one of the equation has been obtained over here. And here this value of r should not be equals to 1. So if r becomes equals to 1, so the expression will become infinity. Therefore this should not be equals to 1. So let me take this as say equation number 2. Now similarly, we will try to eliminate the value of r. So to eliminate r, so once again we will go back to this equation number 1 that we have over here. So this equation number 1. So from this particular equation, we have to eliminate the value of r. So for that, what has to be done? So we will try to separate this r. So keeping this r plus 1 by r as it is, cross multiply this cos theta. Similarly here, keeping this r minus 1 by r, you just cross multiply this sin theta. Alright, so just write down that step here. So we will be getting u divided by cos theta is equals to, it is r plus 1 by r. Then again, v divided by sin theta will be equals to r minus 1 by r. Now because we are having it is r plus 1 by r over here and r minus 1 by r, once again you need to square this value, but we will not just square it, but we will try to subtract it. Squaring and subtracting it. Squaring and subtracting. We will try to obtain, we will try to square this one, u square by cos square of theta minus, because we need to subtract it, minus v square by sin square theta. That will be equals to, on the right hand side you have r plus 1 by r. I need to square this one, subtract this one, minus r minus 1 by r whole square. So if you try to simplify on the right hand side over here, so you can see this is in the form of a plus b whole square. It becomes a square plus b square plus 2 times of a into b, r into 1 by r, right, minus, again this is in the form of a minus of b whole square. A square plus b square minus 2 times of a into b. So further you can see that this r and r will cancel out. You will be getting here this plus r square and this minus r square will cancel out. This plus 1 by r square and this minus of 1 by r square will cancel out. And this r and r will cancel out over here, will just be left out with 2. Here also this r and r will cancel out. You are left out with minus 2. Here also this r and r will cancel out. You are left out with 2. but because minus sign is there, minus of minus will become plus 2. So 2 plus 2 will become 4. So keeping this in mind, you have to square and subtract the value. So this idea you will get because you are getting r plus 1 by r and r minus 1 by r. So from this expression you can guess that by squaring and subtracting you get this constant value 4, so that r is being eliminated. Alright, so r has been eliminated and you got this expression. Alright, or further I can rewrite this value. I'll just cross multiply this 4 on the other side, or I can even write this 4 to be equals to 2 square. So if you just cross multiply, you'll be getting the value to be equals to, it is u square divided by, cross multiply it becomes 2 square cos square of theta minus, you have the value as v square divided by 2 square sin square of theta will be equals to, because you already taken this 2 square on the other side, what is left out over here? Only 1 is left out. So now you can see this is nothing but u by, because everything is square, you can write this value to be equals to, it is u square by, the denominator value will be 2 cos theta square, you can write in this way, minus here it is v square, denominator because it is square I can write 2 times of sin theta whole square, so this will be equals to 1. So we need to obtain the mapping from the z plane to the w plane. So for that let us go back to the equation. Since the equation is given to us, the value of z will be equals to r e power of I theta. So this can be rewritten in the form of modulus of z is equals to r, which represents the equation of the circle with the center as origin and the radius as r. So you can just check it because you already know it, but still I'll show you. You have z is equals to r e power of I theta. So if you take the modulus e power of I theta, but we know the value of e power of I theta, mod z as it is, r radius of the circle will be constant, it will be r itself, e power of I theta will be nothing but cos theta plus I sin theta, because its modulus is there, you can write square root of cos square theta plus sin square theta. Cos square theta plus sin square theta will be 1. So therefore we will be getting modulus of z to be equals to r. So this is standard equation. I just shown you how you got it. So you got mod z to be equals to r. So what does this mod z represents? Z we know its value, the value of z is x plus iy. So if I take modulus of z, it will be nothing but square root of x square plus y square. So if I write down over here, it is square root of x square plus y square is equals to r. So if I try to square it, squaring on both sides, I'll be getting x square plus y square to be equals to r square. So we got the value of r square to be equals to x square plus y square. So what does this represent? This represents the equation of the circle with the center as the origin and radius to be r. So this represents the equation of the circle in the z plane, because it is in terms of x and y, therefore this will represent the equation of the circle in the z plane. Now we have to see how does this equation of the circle will map into the w plane. So let me first write down, this represents the equation of the circle in the z plane. It is in the z plane. So this equation of the circle is having the center as the origin and radius to be equals to r, right? In the z plane with center as origin, and radius to be r, radius as r. So you got x and y in terms of r. So now I have to get x and y in terms of theta. We know that the amplitude of z is represented in the form of theta. So amplitude of z represents theta value. So what is the amplitude that we have? The amplitude that we have is, it is tan inverse of y by x. The amplitude of z is tan inverse of y by x. That will be equals to theta. If I take tan inverse on the other side, it becomes y by x to be equals to, tan inverse goes on the other side, becomes tan theta. Alright, so we got y by x to be equals to tan theta. So what does this represents? Y by x to be equals to tan theta. So this represents the straight line in the w plane where this value of theta will be equals to the constant. That means I can write this to be equals to, again, tan theta represents the slope, so I can write that as m. So y will be equals to m times of, cross multiply this x, so y will be equals to m times of x. So this represents a straight line. This represents a straight line in the z plane. In the z plane, this will be passing through the origin. Passing through the origin. Because y is equals to mx plus c, the standard form. Alright, but plus c is a 0 in this case, therefore it has to pass through the origin. So you got both the curves in the z plane. One is the equation of the circle, another one is the straight line. Now we have to check how does the circle and straight line will map in the w plane. So let us go for different cases over here. So we'll start with case number 1. Case number 1, suppose if I take the value of r to be constant, because I have expressed z in terms of r and theta, so you have to take the value of r as well as the value of theta. So let us take the value of r to be equals to constant. R is constant. So if I take the value of r to be constant in this case, so what will happen to, say, this equation? Can you see the first equation? After eliminating theta, I have got this equation. I have taken that as equation number 2. So let me take that equation. I am taking r to be a constant. If r is a constant, is r plus 1 by r will be a constant. So I will replace this by some other constant, say a, capital A. And r minus 1 by r is also a constant. I will replace this by, say, capital B. So then what will be equation number 2? So therefore equation 2 implies, equation number 2 will imply it is u square by a square plus v square by b square is equals to 1. So where the value of a is nothing but r plus 1 by r and the value of b is nothing but r minus 1 by r. So a is r plus 1 by r and b will be equals to r minus 1 by r. So what does this equation represent? Is it not in the form of x square by a square plus y square by b square is equals to 1, which represents the equation of the ellipse? So standard form equation of the ellipse, you know, it is x square by a square plus y square by b square is equals to 1, so which represents the equation of the ellipse. So I can write down this represents an ellipse. This represents an ellipse in the w plane. So this will be in the w plane. So with what will be the foci? So the focus, what will be the foci? So whenever you are talking about the foci, the standard formula that you have over here, the foci value is nothing but the formula that you have is plus r minus square root of a square minus b square. That is standard form, the denominator values. Same thing if I try to apply over here, it is plus r minus. So this will be the particular value and the y-axis over here, comma 0. So that will be the expression that you have. So if I write down over here, it becomes square root of this particular values, a square minus of b square, that's comma 0. So now if I write down the values of a square minus b square, so I need to calculate this value, a square minus b square. So let me write down what will be a square minus b square. Separately I will try to calculate a square minus b square under root. So a value is known, it is r plus 1 by r, it is squared, minus b square is also squared. Over here you have, it is r minus 1 by r square. So this is under root. If you can remember this expression, squaring and subtracting, this value we have already done it. So I will not be repeating that process. So let us go back over here. Was it not a that I have taken here? A value is r plus 1 by r. I have squared that one here. That is the expression. Minus, that is what you are having, minus r minus 1 by r minus 1 by r whole square. I already simplified this one using the formula a plus b whole square and a minus b whole square. What is the value I have got? I have got the value as 4. So directly I can write this value to be equals to, square root will remain as it is. So this particular value that I have evaluated that as 4. So that will be nothing but 2. So this is plus r minus that you have. So if I write down here, it becomes plus r minus square root of a square minus b square. You have got it as 2 comma 0. So that will be the foci of the ellipse. So we see that when r is a constant, right? When r is a constant, so in that case we get the equation of the ellipse in the w plane. So this is the first mapping. Now we'll move on to the second mapping, right? So let me conclude over here. So we conclude that the circle modulus of z is equals to r. So equation of the circle, that is what I have taken. This particular case already discussed. Mod of z is equals to r. This represents the equation of the circle in the z plane. So here r is a constant. So that is what I have taken over here. R is a constant. So this particular case. So this particular circle where it maps. So this circle x square plus y square is equals to r square in the z plane is now mapping into the ellipse in the w plane. So that is what I need to write over here. Modulus of z is equals to r, where I have taken r to be constant in this case. Alright. So this particular expression in the z plane, maps onto an ellipse. It maps onto the ellipse in the w plane. With foci, right? With foci plus r minus 2 comma 0 represents the focus of the ellipse, plus r minus 2 comma 0. So this is case number 1. Now we'll move for case number 2. Case number 2. So what will be this case number 2? In the first case I have taken r as constant. Now I will be taking theta to be constant. So if theta is constant, what will happen? So let us try to see when theta is constant. So if you go back to the equation, this particular equation where you have theta, right? This particular, if you want, you can take this as the equation number 3. So this is the value of theta. So theta is a constant. So 2 cos theta will completely become a constant. Here 2 sin theta will also become a constant. So let us take these values to be equals to, say, some a and b. So once again, theta is a constant. Equation number 3 implies you will be getting u square by 2 cos theta. I am taking that as a, so it becomes a square, minus it is v square by, you have b square is equals to 1. So what is the value of a I have taken? A value represents here 2 cos theta. B value, and b value represents 2 times of sin theta. So we got u square by a square minus v square by b square is equals to 1. So what does this represents? Because you're getting u square by a square minus, in the earlier case it was plus, it was an ellipse. Alright, it was plus, therefore it was an ellipse. Now you have got minus, therefore it will represent a hyperbola. So this represents hyperbola. Represents hyperbola in the W plane, because it contains u and v, therefore it is in the W plane. It represents a hyperbola in the W plane. So what will be the foci? With foci, so the formula for foci in the hyperbola, if it is a square minus b square for an ellipse, for the hyperbola the foci will be a square plus b square. A square plus b square comma 0. So in this case, you know the value of a to be equals to what? 2 times of cos theta. B value in this case is 2 times of sin theta. So what you have to calculate? You have to calculate square root of a square plus b square. So it will be equals to square root of a value is 2 cos theta and it is squared, plus b value is what? 2 times of sin theta and it is squared. So this will be equals, so this becomes 4 times of cos square of theta. So this becomes 4 times of sin square of theta. Suppose if I take 4 common outside, you are left out with cos square theta plus sin square theta. So this square root will remain as it is. But we know cos square theta plus sin square theta will be 1. So 4 times of 1 will be 4. And we know square root of 4 will be 2. So if I try to plug in that value back over here, in this case, so you will be getting the value to be equals to plus or minus. So it becomes 2 comma 0. So that will be the foci. So we have got the foci to be equals to plus or minus 2 comma 0. So what does this represents? This represents the hyperbola in the W plane. So for this I have taken theta in this case, as we know that theta is equals to constant which is in the Z plane. So if you try to remember theta value, if you have taken theta as a constant in this case, tan theta which is a slope which represents a straight line in the Z plane. So for this I have taken theta as a constant. So this straight line in the Z plane is now mapping into the hyperbola in the W plane. So let us try to conclude over here. We conclude that y is equals to mx. That is what we have taken. Y is equals to mx. The straight line y is equals to mx. The straight line in the z plane. In the z plane. So we have got y is equals to mx when we took theta as constant. So straight line y is equals to mx. The straight line in the z plane maps onto the hyperbola, in the W plane. In the W plane with foci plus or minus 2 comma 0. So the foci for the ellipse as well as for the parabola is the same. Now I should try to plot the graph over here, because we have the first case. So when our first case, we conclude that equation of the circle in the Z plane is mapping into the ellipse in the W plane. So that is what I need to plot. So let me plot the Z plane. It is the circle in the Z plane. So this is your x-axis and this is your y-axis. Now this will be mapping into the ellipse in the W plane. So we have the ellipse in the W plane. So this is the ellipse we have in the W plane. So this circle is mapping into the ellipse in the W plane. So what is the foci you have? It is plus or minus 2 comma 0. So this is plus 2 comma 0, and over here you have minus 2 comma 0. This is the foci, right? let me write down first. This equation of the circle is x square plus y square is equals to r square. And this ellipse that you have is u square by a square plus v square by b square is equals to 1. So the circle in the z plane is mapping into the ellipse in the w plane. The second case that we have taken here, the straight line y is equals to mx. So the straight line passing through the origin over here. So y is equals to mx. The straight line in the z plane is mapping into what? Hyperbola with the foci plus r minus 2. So this foci plus 2 and minus 2. So if I plot it over here, so this will be your hyperbola with plus 2 as one focus, another minus 2 as another focus. So this will be a foci plus 2 and minus of 2. So we can see that this straight line y is equals to mx is mapping into this hyperbola that you have. So the hyperbola, the equation that you have is u square by a square minus v square by b square is equals to 1, the hyperbola in the w plane. So the straight line in the z plane is mapping into the hyperbola in the w plane. So that's the discussion of the transformation w is equals to z plus 1 by z. So that's all I have for today. Thank you.